Hello, my name is Professor Nick, and this is Mad Science. Using my degree in Mad Science Studies from Partnership Schools University, I'll be guiding you through a series of fun experiments in this course that will be sure to blow your mind and expand your brain. Are you ready?
Yeah.
Great, let's go. For today's experiment, we're going to make our own lava lamp. The lava lamp was invented in 1948 by English accountant Edward Craven Walker, and it reached its height of popularity in the 60s, where it was known for grooving up any sort of room. For today's experiment, you'll need a glass bottle or jar, a spoon, baking powder, cooking oil, a cup, vinegar, and your favorite color of food dye. Mine is green, for science. First, take your glass jar and open it up. Then you're going to add about 3 tablespoons of baking powder to the jar. Number 3. Great. Let that sit in there at the bottom. Next, you're going to want to fill the jar about 3/4 of the way with cooking oil. I would not use the expensive stuff here. Pour carefully. Great, you want that baking powder to stay there at the bottom. Next, you're going to mix vinegar and food dye in the cup. Do about a cup of vinegar and a few droplets of food dye. Great. You can give it a mix. I'm going to use my spoon from earlier. Are you ready? We're going to pour this into the jar and make our own lava lamp. But before we do so, I'm going to explain why combining all of these ingredients in the same jar produces a lava lamp. I can tell you exactly what's going to happen because I'm a mad science genius. There are 2 concepts that you need to know to understand today's experiment. The first is that vinegar molecules, or the little tiny components that make up vinegar, are different from oil molecules. Vinegar molecules are attracted to other vinegar molecules because they're alike. Same goes with oil molecules. But when you have an oil molecule that meets up with a vinegar molecule, they kind of look at each other and they're like, I don't know you. You're different. I'm going to go back to my own kind. And they're not attracted and they don't mix. It's sort of like how today we're in a pandemic. You're with your family, you give each other hugs, you like each other hopefully, you're living together, you're in the same household. Great. But if you were to go outside and you were to see another family that comes from a different household, you'll give them a hello, you might give them an elbow bump, but otherwise you're gonna stay 6 feet away because you don't know where they came from, they're from a different household, let's stay apart. That's how vinegar and oil molecules work, except they do that all the time and not just in pandemics. The second concept that you need to know for today's experiment is density. Density is the amount of mass per volume. Mass being the amount of matter or stuff in a substance, and volume being the space it takes up. Here's a question to illustrate density. Which weighs more, a pound of feathers or a pound of bricks? Trick question, they weigh the same, but there is a difference. A pound of bricks takes up way less space than a pound of feathers.
Why is that?
Great question. That's because bricks are more dense than feathers. There's more brick matter per unit of volume per the space it takes up than there is feathers. So you can have a pound of bricks be a not very large pile of bricks because there's just so much brick stuff in there. But a pound of feathers is going to be a lot bigger of a pile because there's just less feathers per unit, less feather matter per unit of volume. So that takes us back to our jar. So first, we know that vinegar molecules and oil molecules don't mix. So when you're going to put them together in a jar, they're going to stay separated. Even if you mix them up real good, they're going to look like it's mixed, but after a second, it'll separate again. So put them in the jar. Vinegar is more dense than oil. So what happens when you put vinegar in the jar of oil? It sinks. And what's at the bottom of the jar?
Baking powder.
You're right, baking powder. So what happens when the vinegar that's green sinks to the bottom and meets the baking powder? Well, there's a chemical reaction that takes place. And the chemical reaction produces carbon dioxide, which coincidentally is also the gas that we breathe out after we breathe in oxygen. So the carbon dioxide is less dense than the oil. And so what that means is the carbon dioxide is going to rise up, producing a lava lamp effect. Okay, are you ready to pour it in now? There we go. Pour in a few at a time. Thanks for joining me today on Mad Science. Please be sure to send in photos of your lava lamps. I can't wait to see them. Also, next time you're out in the street and a family tries to approach you, try explaining to them the 6 feet rule using the oil and vinegar molecule metaphor we talked about. And throw in the definition of density for good measure. Have a great day.